Greetings, math fans. All right, so basically I want to cover two different topics today. One, I want to talk about the graphing calculator and using nderiv. Okay, so we're going to talk about nderiv. So it's using the calculator to take the derivative. And again, this is with your TI-84. Okay. Now you could use the 83, and I know they have the different, fancy schmancy models and everything, but basically it's nderiv, which again we'll show you when I bring up the graphing calculator. All right, and the other topic that we're going to cover is the second derivative test. All right, so let's just talk about the nderiv here. I'm pretty much just going to basically graph this equation: y is equal to 6x squared minus x to the fourth. Okay. And then I'm going to find basically my relative extrema. So I'm going to find maxes, relative max, and relative minimums. Okay, using the graphing calculator, and again using using calculus, as opposed to, you could get a graph and actually find the max and min using the max and min function on the graphing calculator, but that's not what I want to do. I want to actually utilize nderiv to find the derivative and then investigate what's going on with that derivative. All right, so I have a nice little virtual TI here that I'm going to bring up, and we are just going to do some work here now. Okay, so first thing I want to do is I want to type in y equals. Make sure your plots are off, and actually make sure there's nothing. If you cursor down, I'm going to cursor down here a little bit. Sometimes you have like y8 and y9 and y0, you have something in there. You want to make sure there's nothing there, because that'll actually give you an error if it tries to grab something random. Okay, so if I go back to my y1, and this calculator is a little slow on the computer here. Hopefully it's a little faster for you guys. Okay, so I said we're going to graph 6x squared, so let's put that in there. 6x squared minus x to the fourth. Okay, so hit enter. That's our first graph, and then what we're going to do is we're going to graph the derivative. All right, and it's easy to graph the derivative. This is what we do. We basically use nderiv, which you have math 8. So I can cursor down or just hit math 8. Math 8 is nderiv, N-D-E-R-I-V, and then here you get it nice d by dx. Now if you have just N-D-E-R-I-V with a parenthesis, it's like the old operating system. You basically have to type in your y1 comma x comma x. Okay, so but if you have this one, hopefully most of you have this. You put d by dx in there. Okay, and then you want to put, now you could type the 6x squared minus x to the fourth, but I just want to put y1, and I do that by hitting vars, cursor over y bars, choose function, and then you have y1, y2, so I'm just going to hit y1, so enter, and that puts y1 in there, which is what the first equation was. Kind of handy. And then I'm going to cursor over, and that x equals x, because it's going to find it every value. Okay. Now some of them are color, which actually makes it a little cleaner. This is not in color, no big deal. But now you hit zoom 6, or zoom standard. Okay, and it's going to graph it. That's the original function, and the next one is our derivative function. Okay, so here's the deal. Actually, I'm going to get rid of. Well, here, if you notice that on the real function here, you could turn it off. This is kind of a nice little thing. If I hit y equals, I can turn off by cursoring over the equal to sign, hitting enter, and it's no longer highlighted. So if I just say graph, it's only going to graph the first function, or the graph that's highlighted. It's kind of a handy little feature. You can turn things on and off, so things are not cluttered. But again, when you have a color calculator, it's a little bit clearer. So here's our graph, and we're trying to do again is we're trying to find relative maxes and mins. And if you notice, we have two relative maxes right here. One's positive, one's negative, and then we have a relative min right over here. Okay, right in the middle there. And all right, so if I go and put this back on here again, so I hit y equals And just for the heck of it, I'm going to turn off this one, and I'm going to turn on this one. Okay, I'm going to hit graph again. And now it's just going to graph the derivative function. So remember, I had 2 maxes and 1 min. Now remember, this is the derivative function. So think about it. Above here, where I'm pointing here, this is a positive slope. So take your hand, it's a positive slope to a negative slope. So that's a max, which it was. That value right over here was a maximum for the first graph. Okay, and then if I go to the next time it crosses the 0, because remember, where f prime is equal to 0, that's where you have relative max and min. So here it's negative, so take your hand, go negative to positive. That's a relative min, and that's kind of right close to 0 here. And then here we have another one here, again with 0, it's positive to negative. So take your hand, again, positive to negative, that's another relative max. So here I have my relative min and max on this derivative graph. All right, and that's what you're going to be doing to explain where you have relative max and min, as opposed to just using the max and min function, which you do have that, by the way. If you hit second calculate, okay, you do have minimum and maximum, but that is not using any calculus, which you'll not get credit for. Okay, you have to actually use the first derivative and do your interval testing. You can do it visually now because we actually have a graph. So again, if I have, this is the graph again. What I'm going to do is I'm going to keep both graphs up there. It looks a little complicated on this one especially, but I'm going to show you how to go back and forth between the 2 graphs. So I'm going to hit enter again. Now they're both highlighted, so if I hit graph one more time, it's going to show me the first graph, and then it's going to graph the derivative. So really what I'm trying to do is I need to figure out what this value is for x. Okay, I know the y value is 0, so you have to find our zeros for the derivative graph, which was that second graph. So what I'm going to do is I'm going to say second calculate, and I'm going to do zeros, because I want to see the first place is going to cross. Now here's the deal. It says left bound and right, or left bound question mark. Now look what equation is showing up there. 6x squared minus 4x to the fourth. I don't want to find out where that's crossing the x-axis. What I want to do is I want to find out where the derivative is. So in order to move it between functions, you use the up arrow and the down arrow. That moves it between functions. So watch, if I hit the up arrow, watch what goes from y1 equals 6x squared minus x to the fourth. Watch that. y2, end derivative of y1 comma x comma x. So it shows, and I can keep kind of going back and forth, but it shows basically my y1 and y2, it fluctuates back and forth. So when I want to find my left bound, I want to do it on the derivative function. Okay, so you use the left and right now to move that cursor. See the cursor? It's moving, and I want to go to the left bound, and then I was on the left side. So it's on the left side before crossing that x-axis. So I'm going to hit enter, and then it says right bound. So I'm going to go to the right side. Okay, there's the right side. Hit enter, hit guess, and there we go, negative 1.732. Okay, so now you're like, well, that's the x value. Now if I ask you, hey, what coordinate is there a relative extrema? Now obviously, again, it went from a positive, or went from a positive slope to a negative slope, so this is a relative maximum. So I would say there is a relative max at x equals, and again, that's easy, negative 1.73. Now if I said, hey, what's the coordinate of that relative max? This is kind of a cool little feature. Check this out. I actually see how it's reading that's the 0 for the first function. Watch, if I hit the up arrow, now I'm in the new function, or the original function, 6x squared minus x to the fourth, and here it is. There's y9. So it gives me a coordinate just by cursoring up. It puts me in the other on the other graph. So that's my coordinate, negative 1.732051 comma 9. It's pretty cool. So again, my investigation would be there's a relative max at negative 1.732 comma 9. Since, okay, I'm kind of saying all this because we've seen this before, but since f prime of negative 1.73 is equal to 0, right? And f prime of x is changing from, again, from positive to negative at x equals negative 1.732. Those are the words you're going to say. So you're saying all the words that we've learned, except now you're just looking at the graph and kind of picking things off. There's no interval testing here because I have a graph. Positive to negative is a relative max. Okay? That's kind of cool. So again, let's take a look at our relative min, which is going to be right here, if you guys can see where I'm cursor right by the origin. So again, I'm going to do second, calculate, 0. Okay, left bound. So make sure I'm in the right graph. Well, I'm in the wrong graph, right? So I'm going to cursor down, and you want the end derivative. There we go. And let's go to the left of that. Okay, so that's to the left of that where I'm going to cross the axis there. So hit enter. And then I go to the right, so we'll cursor a little bit more to the right. There we go. It's a little hard to see. If I get rid of the other graph, the first graph, and unhighlighted that, I wouldn't be able to go back and forth between functions because it would only have one function there. So I just got to be careful. Okay. Anyway, my guess after I pick the right bound, guess is 8.452e negative 18. Think logically. What does that mean? It really means 0. So I actually have a relative, and again, what's going on with it? Right, I'm going from negative, take your hand, negative to positive. So I have a relative min at 0, 0. Okay? But I need to go to the other function, so I'm going to hit up arrow. Okay, so here it is, up arrow, and again, this is e to the negative 18, and this is e to the negative 34, which the coordinate is 0, 0. That's where you have a relative minimum. Okay, and again, so you're going to tell me there's a relative minimum at 0, 0 since f prime of 0 equals 0 and f of x is changing from negative to positive at x equals 0. Those are the words you're going to use. Okay, you guys should be really familiar with that. Okay, so the last thing I'm going to do is same thing here. I'm going to do second calculate. I'm going to do another 0. Okay, and left bound. So again, and make sure you have the right function up here, which I'm going to cursor up. I'm going to do end deriv. So I'm going to go, it's the left bound before we cross the x. And I'll go 1 back up. Okay, so that one, and then on the other side, the right bound. Hit enter, and there we go. So I have positive 1.73. Remember, the other one is negative 1.73. So 1.73 comma 0. That's where my derivative is. But I need to figure out what the y value is for the actual function. So I'm going to cursor up, and there it is. Now I have my new function. So here's my value, 9. So it's 1.73 comma 9. That is the coordinate of the relative max. Okay, so again, what words you're going to use? You're going to say there's a relative max at 1.73 comma 9 since f of 1.73 is equal to 0 and f of x is changing from positive to negative at x equals 1.73. And those are the words, and that would give you full credit for your problem. Okay, but that is the use of your graphing calculator. I think it's just a great tool to be able to find derivatives using the calculator, and even graphing the derivative graph. Okay. All right. Cool. So let's move on to our next topic here is the second derivative test. Okay. So second derivative test. So of course, second derivative test is using f double prime of x, and we're going to use f double prime of x to determine relative mins and maxes. Okay, Second derivative test. So let me just kind of give you a quick example here. If I gave you an axis here, and I said that this was a critical point. Okay, that's a critical point. So basically, f prime of x is equal to 0. So I'm going to have two cases here. So the first case, again, we're going to use the second derivative test. The first case, let me put that point back here. Let's say the graph looked like this. Okay, so what would you guys tell me about this as in terms of second derivative? Wouldn't you guys say, oh, it looks like it's concave up? So f double prime of x, isn't that, oops, here, sorry, isn't that greater than 0 because it's concave up? So think about what would make that point then. This would be a what? It is a relative minimum. So that's literally what you do here, math fans. We're not doing interval testing. We're not going, okay, we have this coordinate, of let's say 3, and we're checking 2, or checking 4. We're not doing that. That is the first derivative test. This is the second derivative test, and you're looking at, basically you're looking at concavity. So think logically. If this is concave up, that's a low point here, and so that's going to be relative min. Okay? And my other case is, of course, the same point, and if it was this way, concave down. So that means f double prime of x is less than 0, or concave down. And if that's the case, well, look at it. What is it? It's a relative maximum. Okay? So that's basically what you're going to do is you're using the second derivative to determine if it's concave up or concave down. And if it's concave up, now it's a little counterintuitive because you think concave up, you think, oh, that is concave up is maximum. But no, think of it logically, this is concave up. That means it has a low point. That means a minimum. This is concave down, so that means it has a maximum point. Okay, got to remember that. So really the word you're going to use to describe something, you're going to say, so here are your words. You're basically going to say, just let's say that value is 3 that we were talking about. So f of 3 is a relative max since f prime of 3 equals 0 and f double prime of x is less than 0. Okay, so remember, if it's less than 0, it's concave down, which makes it, think of it that way, right? It's a maximum point. So really those are the words you're going to use. Pretty key stuff here, math fans. Okay, and now when would you use this? Well, I would specifically tell you using the second derivative test. So you better use the second derivative test, because if you use the first derivative test, I'm not going to give you any credit for it. Okay, and you're like, well, why would you do, what case would you even use that then? Why would you use one or the other? Well, I might actually give you a chart. What if I give you a chart and I don't tell you anything about what's going on before it? If it's a negative slope or a positive slope, I don't tell you anything about the second or the first derivative, but I do tell you something about the second derivative. Well, of course, once you know the second derivative, you know if it's concave up or concave down at that location, and then you can tell me if it's a max or a min. Okay, so it's pretty easy, but that is what second derivative test is, literally looking for concave up, concave down, and then determining if it's a max and min. All right, so that's it. We got a little n deriv, little second derivative test, and we are good to go. That's it, math fans. Adios. Goodbye.